This week's topic is an introduction to Truelight color spaces, Baselight's built-in color management system. I will start with explaining foundations about Truelight color spaces, or short TCS, and in the second part I will give you easy to follow guidelines so that you can achieve the best results. Okay, let's begin. Truelight color spaces is the native color management system of all Filmlight products, Baselight, Daylight, Baselight editions and BLG tools, etc. With a color management system, you don't select individual color transforms, for example like a log C to ACES transform, but instead you are tagging the image at different stages. For example, you're tagging input color spaces, working color spaces, and also the output color spaces, for example, for your display or for specific renders. Other color management systems are, for example, OCIO, OpenColor.io, or Apple ColorSync. So a color management system can accommodate many different color management workflows. And what are color management workflows? These are specific sets of rules and specific color transforms that are applied in a predefined order. Probably the most popular color management workflow is ACES, which all of you have probably already heard of. Other color management workflows are our Truelight CAM, ARRI ALF 2 and 4, Red IPP2, the Cineon workflow, for example, or other custom workflows. So the important thing to understand is that Truelight color spaces is not restricted to the Truelight CAM color management workflow, but it can accommodate all of these color management workflows and all kinds of custom workflows that people want to use. One of the main differences when working color managed is the starting point of your grade. Typically the image should look like the one here on the bottom, so very similar how you would perceive the same scene with your own eyes on the set, and not washed out like that image here on the top. This works because the software is aware of the input color space that we are feeding into the color grading, and it is also aware of the display's capabilities and what kind of color space the display expects. And the end result is that we should have a similar perception as a starting point between the set and the display. Let's talk about naming in Truelight color spaces. This is a very important foundation, and it can also help you with troubleshooting. All color spaces that we create and distribute follow the same naming scheme. It starts with the group, followed by a colon, and the group can be a manufacturer, for example, of cameras, or it is the dominant SMPTE or ITU standard of a color space. After the group, we have the transfer function. The transfer function is the relationship of the signal values to light energy. I will show in a moment with some examples what that means. Then we have a forward slash and the primaries. The primaries are the relationship of the signal values to the CIE system. So for example, these horseshoe and triangles that you have probably all seen before. Some color spaces have additional info followed by another forward slash. For example, here the HDR color spaces have their peak white roll-off defined in that additional info field. Some camera color spaces have a tag there, for example, if they're optimized for tungsten or daylight scenes. Let's look at some examples. First, the camera color spaces here. So here I have two different transfer functions, linear and S-log3, and Sony also uses two different primaries for the modern cameras, sGamut3 and sGamut3.cine. Let's have a look at one of the popular display color spaces, this one here, Rec 1886, 2.4 gamma, Rec 709. So what does that actually mean? Rec 1886 was the ITU standard where an HD video display was finally standardized. Rec 709 is the standard of an HD video camera, not a display. And Rec 709 does not follow a 2.4 power law or gamma function. So in Rec 1886, the HD reference display was defined, and it was defined to have a 2.4 power law gamma transfer function and to use the primaries that were established with the Rec 709 standard. And so this is how we read these 3 pieces of information here. Okay, let's look at an example. So here I have a shot, and I have it in the timeline in 4 different input color spaces. The first one here is Sony linear S-Gamut 3. And so here you can see inside layer 0 in the sequence operator we have the input color space selector. So what happens if I use a different input color space? So let's first change the tone curve. So currently we use linear S-Gamut 3, and now I switch that over to S-Log3 S-Gamut 3. So the primaries stay the same, but we change the tone curve. So we can see, okay, so this is clearly wrong. So very easy to identify something is going wrong, and that's not the right input color space. So we switch it back to linear. But what if we change the primaries? So what if we don't know that this is S-Gamut 3 and we think it might be S-Gamut 3.Cine? So now I change that, and you can see it's barely noticeable in that case. So it's just a minimal change here of the colors, the hues, and the purity of the colors. Also, I plotted here the input color spaces with that gray dotted line in that CIE XY diagram here. So the primaries, they define the coordinates in that CIE diagram of the red, of the green, and of the blue primary of that color space. And here we can see in that with that gray triangle, so this is S-Gamut 3 and this is S-Gamut 3.Cine. So we can see some of the points move around, and so that means what kind of red, so what kind of hue does it have, and what kind of purity or intensity does the red have, and the green and the blue. And when we change the transfer function, once again, let's change that, then we can also see a strong difference here also on the Luma waveform, whereas if we are just switching between different primaries, we see that the Luma waveform roughly stays identical. So I can now also change to, for example, the ACES linear AP0 input color space. So now we can see a stronger misalignment of the colors in the image, but still we can see that the brightness and the contrast are still plausible because the tone curve or the transfer function is still fitting, or I can use this linear space here, or here linear with the smaller Rec 709 primaries, which then gives us a more desaturated result. So let's move to the next shot. So this one here is encoded with linear S-Gamut 3.Cine, and I guess you get the idea. If I would now set this to S-Gamut 3, we also see a slight mismatch in colors, but also we can see it's hard to eyeball which one should be the right one for these images. So clear communication when we exchange files is really crucial. These ones here are now the log version of the shot. So this is S-Log3, S-Gamut 3.Cine. And if we now select the linear one, but with the same primaries, we can see it goes in the opposite way. So now, again, very clear, this is the wrong input color space in that case. So typically, when we don't know the exact input color space of a shot, it's a good strategy to first try to eyeball the transfer function and then try to eyeball the primaries, which is much harder as a second step. Another thing to note is that what I showed about the linear scene referred color spaces that all share the same transfer function, this is not true for the log color spaces. Every log encoding of every manufacturer is slightly different. So if I use, for example, Aries log C3, we can see it's shifting not so much, but at least slightly between S-Log or here Panasonic V-Log, for example. But another very important thing to take away from this example is that now I have set the input color space correct for all 4 clips here. And you can see here also the triangles moving around. All 4 images look identical. So as long as the input color space can accommodate the whole dynamic range and color volume of the camera, it doesn't matter which one we are choosing, or at least it doesn't influence the look of the image. So all 4 images look the same and all 4 images will also grade identical. One thing you might have noticed is that all color spaces in Baselight are grouped into 2 groups. The first one has a camera icon. These are the scene referred color spaces. The second one are the display referred color spaces, and they have a display icon. So let's take a closer look at that. On this slide, we have the scene referred color spaces on the left in blue and the display referred color spaces in black on the right. There's a clear divider line here in the middle. Scene referred color spaces, they store light energy from a scene that a camera captures. So this can, in most cases, these are real cameras, but this could also be synthetic cameras like CG renderers, for example. They can also produce scene referred color values. And the signal values, they really describe the amount of light that hit the camera sensor. In comparison, display referred color spaces, there the signal values describe the light energy emitted from a display. And this is something fundamentally different because displays have a fixed dynamic range, and that's what some people call a closed domain. So we can expect certain parameters from a given display, for example, peak white luminance, black level, or the color primaries. Whereas a scene is sometimes described as open domain. So a scene has an unlimited dynamic range, although a given camera does not have an unlimited dynamic range. But during grading, we still want to be able to push things around in an open domain space. So we don't want to be constrained by the limits of a given piece of equipment. So the state-of-the-art way of working, and this is also what we recommend everyone to do, is capturing in scene referred color spaces and also using scene referred color spaces as working color spaces during post-production. Scene referred color spaces also have other advantages. For example, they're very popular in VFX because they allow physically based rendering and compositing, and this is also true for grading. So physically based grading is a thing, at least in Baselight. And so what are scene referred color spaces? Typically, they are either having a linear transfer function, so that's then also sometimes referred to as scene linear, or they use one of the various log encodings. The idea of scene referred color spaces is to store the light energy from the set in a documented way. One of the disadvantages of scene referred color spaces is that you can't view them directly on a display. So we all know that when we throw a log image onto a normal video display, the image looks washed out and does not look right. So this is one of the disadvantages of scene referred color spaces. So we need to always apply a color space conversion to view them in a correct way. So we need to bring them over into the display referred world here. So we need to cross that border into the black area to be able to view an image on an actual real world display. And that crossing is not trivial. In state-of-the-art pipelines, this is handled by the Display Rendering Transform, short DRT. So that's an acronym that you will see a few more times in today's session. There's also the legacy way of working, where the colorist just takes the log image and then is gradually grading it until it looks right on a video display. This is what we refer to sometimes as the telecine style of working or the display referred working style. This style has worked well in the past, but for modern state-of-the-art pipelines, it is not capable anymore because it has certain limitations. So the general idea in a state-of-the-art pipeline is to keep the image as long as possible on the blue side here in the scene referred domain. And only as the very last step, when we create the final deliverable, then we are crossing the border over into the display referred world and then are baking our display referred finally rendered image into a file that we deliver. So display referred color spaces are ideal to distribute mastered and graded material, and scene referred color spaces are ideal to exchange ungraded and work in progress material. Also, exchange with VFX should be handled only in scene-referred color spaces. But of course, when we're working on a scene-referred image, we always need to use color management to accurately view the image. But this viewing transform, so the DRT, is never baked into the image until the very last step. When we are working in a scene-referred color space, sometimes we're handed display-referred footage, for example, from certain broadcast cameras or consumer cameras or prosumer cameras, or maybe footage captured by smartphones or stock footage, you name it. What do we do then? So then we need to convert display-referred footage into a scene-referred state. And this is then done by the inverse display rendering transform, or inverse DRT. And this process is not so straightforward. So that's why it's a zigzag line here. Let's think of a quick example. Let's say we have an ARRI camera and we can capture in Rec 709 2.4 gamma or in log C. If we capture in 2.4 gamma Rec 709, which is a display referred color space, and then convert that back to log C, I guess to all of us it's clear that we can't expect the same image fidelity and especially dynamic range and color volume that we would expect from a native log C capture. So inverse DRTs are important and often required and necessary, but we should always avoid going from the blue side to the black side, back to the blue, back to the black, etc., etc. So the general idea remains: stay on the blue side as long as possible and only cross over to the black side once as one of the final stages in image processing. Another thing to note is that conversions between different scene-referred color spaces are practically lossless. We've seen that in that example with that Sony Venice shot. So we can basically convert from one scene-referred color space in Baselight to another scene-referred color space and then back to the other one without any image degradation. Also, if we convert between different display-referred color spaces of the same viewing condition, for example, between X prime, Y prime, Z prime and the P3 color spaces back and forth, this is also practically lossless. But as soon as we're crossing that border, we are using non-trivial transforms and we should be careful. On this slide, we have a more simplified way of looking at the display-referred telecine style grading workflow. So we have the scene that is shot by a camera, we have our color grading, and we have our grading display. There is a direct connection between the grading system and the display, and the colorist starts turning the wheels and the knobs, etc., until the image looks nice on that display. So the colorists are directly manipulating the light that is emitted from the display. So they are really grading the light on the display here in that case. That's why it's called display referred. One of the big advantages of that working style is that we can take images, send them to the display, and they look correct. We don't need any additional color space transformations. So now let's look at scene referred grading in contrast. So here we have three stages again: the scene captured by a camera, our color grading, and our grading display. But in scene referred grading, we are grading the light in the scene in an abstract way, and we're then piping that graded scene through the DRT and process it for a given display. So when we are grading a scene warmer, it's more like changing the color temperature of the light on set in scene referred grading. And then we're processing that graded scene referred image onto a given display through the DRT. And sometimes I use that analogy of seeing the DRT as a specific camera for that display. So let's imagine we have a standard HD video Rec 1886 video display here, and we're processing with our DRT, basically with our HD video camera, our graded scene for that display. So what are things that we can do? For example, in scene referred grading, we can change the exposure by exactly one stop inside the grading system. We don't need to go back to the camera and change the exposure there. So we can do really accurate exposure corrections inside the grading system. So this is only possible with scene referred grading. And another big advantage is that we can exchange our virtual camera here. So we can take out our standard dynamic range video camera and we can put in, let's call it an HDR camera, and can then shoot the same graded scene and process it for an HDR display, for example. And this is what the DRT family is doing. It processes the graded scene referred image for a given output display. One thing to mention is that a graded scene referred image is not 100% scene referred anymore. You could also call it indirect output referred, because when we graded the image, we had to look at a certain kind of display. So some capabilities of that grading display probably influenced our decisions while grading scene referred. So some people call that stage indirect output referred or similar, but we will not go into more detail here. This is an overview of a typical scene referred color management workflow. On the left side, we have our sources, and all of our sources are tagged accordingly with the input color spaces and then are automatically converted by TCS with the shader into the common working color space, which should also be a scene referred one. Ideally, all sources from real cameras or renders should have scene referred color spaces, but we all know that there are sometimes cameras that shoot in display referred color spaces like Rec 709, or we might have footage that was already graded and rendered to a display referred color space. And in these cases, we will then apply the inverse DRT and the Truelight color spaces shader to also convert these clips into our common scene referred working color space. And this is here where all the work is happening. And on the output side, we have the DRT family that then converts to the different output viewing conditions and color spaces. Let's jump back into Baselight and have a look at some real examples. So I will open an important view. It's called the color space journey. And in the color space journey, we can verify what Truelight color spaces is doing while it processes the image that goes to the video output. So in this case here, this is a raw clip, an ARRI raw clip. It's automatically decoded to ARRI linear ARRI white gamut 3 as the input color space. So we can see here Baselight detected this is an ARRI raw clip, so I know what to do with it. So it gives us the automatic option, and we should always use that one. Then the first conversion, the input color transform, goes into the working color space. In this case, we use the FilmLight T-Log E-Gamut. It's also a scene referred color space. My viewing color space is on my Mac here currently set to sRGB. That's a display referred color space, which makes sense. So Baselight now needs to cross from the scene referred to the display referred domain. And whenever it needs to convert from scene referred to display referred, Baselight automatically applies the DRT. In this case, I configured Truelight Cam version 2. And here it uses the Office 100 nits viewing condition for sRGB display. Let's do something different. I open the scene settings, go to Format and Color. And now I'm changing the working color space from T-Log to a display referred one. I use Rec 1886. Now we can see a different color space journey. We still have the scene referred input color space, but now because the working color space is already display referred, Baselight needs to apply the DRT inside that input color transform here to the working color space. And the color space journey shows us a hint that this is not an optimal working style, because we might not be able to leverage the full dynamic range of the captured image during grading. And then we have a simple conversion from the working color space to our viewing color space, because this is now just display referred to display referred. Okay, let's set this back to T-Log E-Gamut and move on to the next shot. This is an ASUS linear AP0 EXR. It's also called an ASUS 2065-1 file. It has a linear tone curve and the large AP0 primaries that we can see here. In this case, Baselight is able to pick up the correct input color space from the metadata of the EXR. But this is not always the case. It could happen that the image comes in with the default EXR color space, which is linear and Rec 709 color primaries, and then it would look wrong color-wise. So then you might have to guess which is the correct input color space for that scene linear image. So another piece of advice, always be very precise with the labeling of your files. Don't label a file just with linear, but always label it with tone curve and primaries. And of course, we have access to the full dynamic range of the source clip. Here we can see the highlights look blown out without a correction. But if I correct the shot down to a darker exposure, we can see all the details come back in the highlights. And of course, the same happens here in the shadows. The color space journey of that clip looks very similar to the first one. We have an automatic scene referred input color space. The rest is the same. The next clip in the timeline is a Rec 709 video file. And so this is a display referred input color space. So now Baselight needs to cross the border from display referred to scene referred on the input side. And it needs to apply the inverse DRT first. Then we are grading, as usual, in our T-log egamut working color space. And on the output side, it then applies the normal DRT going back into the display referred world. So the color space journey warns us that this is not ideal, but it is required in that case because our clip is available only in a display referred input color space. So this is not uncommon. Let's proceed to the next clip. So this is log C material, but it was transcoded to ProRes prior to grading. And so here Baselight is lacking the correct input color space for that clip. So we can see it looks washed out. Baselight assumes that the most probable input color space is Rec 1886, but this is clearly wrong here. And so I need to manually tag that clip as log C3 Arri white gamut 3. Now it looks correct as a starting point. It might require some white balancing to balance out that warm light, but that's then part of the grade, of course. This concludes the first part. Now continue with my 5 guidelines for you. The first guideline is never lie to Baselight or TCS. And here the most important part is the viewing color space. Always set the viewing color space according to your display capabilities and settings. This is really the most important piece of the whole color management, because if you have a mistake here, the whole card house collapses. Then the whole what you see is what you get paradigm is not true anymore. Another important part is the input color space. Always tag your input color space according to your footage, at least if you know the correct input color space for your footage. If you don't know, you might have to eyeball it, but that's a non-ideal scenario. And if Baselight suggests an automatic or an from metadata tagging, you should usually go with that, unless you know otherwise, like in my last example with the transcoded material where the metadata of the file was actually wrong. Also, if you apply LUTs in the stack, set the input and output color space that the LUT expects accordingly in the LUT operator. So I show that now with an example. So here we have our shot again, and let's insert a LUT operator from the color menu. So this is a show LUT that I made once, and I always label my LUTs with the input color space and the output color space of the LUT. I select that LUT and the image looks completely wrong because we haven't set the correct input and output color space of the LUT yet. So we see that the input color space is log C, so that is log C3, Arri white gamut 3. The output color space is Rec 1886, and now we see a plausible image again. Let's examine the color space journey. Here we can see the LUT operator. It's even showing the layer number of the LUT operator, so it's currently layer 1, and it shows that we are converting from scene referred log C3 to display referred rec 1886. So downstream of that LUT strip, the image is now in display referred rec 1886 color space. And when Baselight finally needs to convert to our cursor color space here, sRGB, then it just needs to apply a simple conversion from 2.4 gamma to 2.2 gamma here for sRGB. So Baselight is not applying the DRT here anymore because it's not required. The border crossing between scene referred and display referred is now handled by that LUT. So if I bypass that LUT strip, we can now compare the output of the DRT, Truelight Cam V2, or the processing inside that LUT. So we are really skipping the DRT now with that kind of workflow. And you should really be aware that with this kind of LUT workflow, we can't go easily to HDR. We are really skipping the DRT family, which brings us advantages. So you should really be aware of that. But if you want to use a LUT, this is the right way of doing it. And ideally, the LUT should be log to log, how we call it nowadays. It should be scene referred to scene referred color space. That would be a better solution. And if you are unsure about the correct input and output color space of a given LUT, probably the best idea is to not use that LUT at all. Let's move on to guideline number 2. Use a DRT family. Through a DRT, we gain the capability of grading in a scene referred working color space, which brings certain advantages. And through a DRT family, we gain the capability of outputting not only to SDR but also to HDR. Guideline number 3. Use a scene referred working color space. The working color space should have a log transfer function for color grading, and the best choice is the one that matches your selected DRT. So for ACES, it would be ACES CCT. For the Truelight Cam DRT, it would be T-log E gamut. For ARRI ALF2, it would be log C3 white gamut 3. And for ALF4, it would be log C4 white gamut 4. For red IPP2, it's red log 3G10 and red white gamut RGB. Let's have another look at an example here in Baselight. So I have that shot here. I open my scene settings, format and color. In the DRT drop-down menu, we see all of our options, but we should only use the ones that have the icon with the multiple S curves. That is also a little bit brighter. So these are the DRT families. So that means they can output to multiple viewing conditions, and typically that means not only standard dynamic range, but they are also able to output to high dynamic range. So an ACES pipeline would look like this: ACES RRT 1.1 plus, DRT family, and ACES CCT as the working color space. So the DRT has an effect on the starting point of our grade, but changing the working color space, as long as there is no grading applied in the timeline, does not influence the look. As soon as we start grading, it also has an influence on the look. So let's jump to ALF, or IPP2 would look like this. How to pick the best DRT and working color space for your project is a topic for another day. Let's move on to guideline number 4. The timeline is always full range. So far I haven't talked about legal and full levels. And here's the thing. Truelight color spaces is optimized and really built for only full range images. So it always expects full range images when it handles color space conversions. So if we are dealing with legal range levels, doesn't matter on the input or on the output side, then we need to scale them accordingly. So if we have full range input, we don't need to do anything on the input side. But if we have legal range input, then we need to check that small legal to full scale button inside layer 0. I will show that in a moment where it is in the user interface. And on the output side, if our display that we have connected, typically via SDI, expects legal or sometimes it's also called limited range, then we need to set the SDI output scaling either in the display menu or in Baselight setups accordingly to full to legal. Otherwise, set it to no scale clip if the display expects full range levels. And the last point is during render, if we are rendering to a file format, for example ProRes, that expects legal levels, then we need to apply the full to legal scale video LUT. Full range file containers, they should use here also no scale clip. And two more things to mention. If you find any kind of legacy color spaces on your machine, they should also have that user icon next to them because they're not natively in Baselight anymore, that have a legal part in their naming. Somehow avoid these kind of color spaces. They shouldn't be used anymore in Baselight. You should be able to apply all required operations just with these three options here. Also, please avoid the clipped and soft clipped scaling options. They should also not be required anymore. Let's have a look at an example here. So here we have a ProRes clip. It's in a display referred input color space, Rec 1886. So this one is already graded. We're loading it into our timeline. Baselight automatically already checked the legal to full scale option here, just based on the metadata that it read from the file, which is the right thing here. So if I uncheck this, now we treat the file as it would have full range levels, and we can see now the black levels are a little bit lifted. If you're unsure about the right choice here on the input side for a certain clip, then having the legal to full scale off is the safer option. But here in this case, it's pretty clear this one is the right choice. Let's move on to our final slide about legal and full scaling. So this is a general overview that I put together for you. And so this should give you some guidance about the correct choices for certain formats here on the input side. Here are the display settings during grading, and on the render side, these are the typical choices. And if you want to learn more about legal and full scaling in Baselight, check out our Baselight Q&A webinar. In there, I explained the whole topic in a little bit more detail. Let's come to our last guideline, number 5, rely on default settings. There are various advanced settings that I haven't covered today. The mastering color space, grade result color space, several color matrices on the input side and output side, the mastering white point, etc. There are a few more options. If you don't understand a parameter in Baselight in the color management, it's best to leave it on its default setting or leave it on an automatic setting if that is available. Let's have a quick look at the scene settings. Here, for example, in the advanced section, we have the mastering color space. We have an automatic option here, automatic from DRT. It's usually best to leave it on that setting because the automatic settings and our default settings are really built around the best practices in the industry. So for most cases, this should be the right choice. Also, automatic options have the advantage that they can adapt dynamically to different parameters. So for example, if the input or the render color space or viewing color space changes, they will adapt dynamically and still do the right thing for that scenario that you're now doing. So automatic is a good thing in Baselight, and we are also trying to be as opaque as possible about our automatic processes. So we try to show them all transparent in the color space journey so that you're still aware about what is actually going on under the hood. Okay, this was a lot of content for one session. So thanks for staying with us today. So we know it's not an easy topic, but I hope that I was able to give you a smooth introduction into it. And so I think we covered all of the important things, questions in the chat. Okay, so have a great day, happy grading, and see you next time. Bye-bye.